Hey Nat, what you doing?
Hey, I'm working on these web assigned questions. The one that our professor gave us for physics. I've literally just been stuck to my laptop this entire time.
Are you doing the one that was due this Wednesday?
I'm doing the ones due Sunday, but I'm still kind of lost to be honest, and I don't know why.
Yeah, same. What part specifically are you talking about though?
Okay, so I understand the concept of kinematics, right? But I'm still making my graphs, the ones about velocity and position wrong, and I don't know why. I think it's because I haven't seen a good example that's really made it click in my brain. Or I'm probably really tired and I'm not trying.
Yeah, that's exactly the one I'm lost about too. I just need a good problem that makes it make sense for me?
Do you know what we could do? We could probably call Michelle because I know that she said that physics was pretty easy for her, to be honest. So I feel like we should try.
Yeah. You know how she is. She might be at work. I don't know.
I mean, it's a simple question, to be honest. So I'm just gonna add her and see. Hopefully, she picks up because I can't keep staring at this laptop screen for hours.
Hey, I just got in the car.
All right. I'm gonna try and make it quick. So, do you understand those graphs that we're doing in physics? Does it make sense to you? Can you help us make sense of it as well? Because we're kind of lost, not gonna lie to you.
Yeah, do you mean the position and velocity ones?
Yeah, we're talking about those questions, those graphs.
Well, I'm running late, so I could just show you an example while I'm driving. There was an example that I saw in a textbook about this person driving somewhere, so let's imagine me driving somewhere as our real-world example. To make a position versus time and velocity graph, I'm going to measure my distance to the grocery store in kilometers and the time that I've traveled in minutes and the speed throughout the trip. To make our graphs, I'll be using this phone as a GPS to measure the time that I've taken to drive and the distance that I have traveled. And to record our data, I will be stopping at every red light. And at those red lights, I will record the time that I've taken so far and the distance in kilometers that I have driven. And I'll do this until I get to the grocery store, and this will make our position versus time graph. Okay, so I'm ready, and you guys can sit back and enjoy the ride with me. Okay, so now I'm at the grocery store and I'm gonna go back home so I can collect the same data that I collected now, and then it'll make the whole position versus time graph from me going to the store and me going back home. Okay, so let's go. Okay, so now I'm back home from the trip and my total time to the grocery store and back was 14 minutes. My kilometers in total to the grocery store and back was 5.794, and my speed stayed at 20 miles per hour since I was in a school zone, and that is the limit by law. So I just try to stay as constant as possible. So with this information, we can make our position versus time graph, our velocity versus time graph, and our speed versus time graph. Thank you.
Okay, so how the heck would all these data points look on graphs?
Let's start off with my position. I calculated the amount of miles it took to make a round trip and converted it into kilometers, which told me that my total distance traveled was 6.275 kilometers in 14 minutes.
Which means to go there, you traveled about 3 kilometers. Wouldn't the graph just be a triangle?
Yes, exactly. When going to the store, I am heading in the positive direction of y, which means that the slope will increase. When I come back, I begin to head in a negative direction.
Yeah, which is basically what position is all about. Because in our situation, it's equal magnitude but opposite direction. So that makes sense.
Okay, so I got position, but if velocity was constant, wouldn't it just be a straight line?
Actually, our velocity versus time graph would not be a straight line, but you're close. Let's just pretend that My grocery store trip was a straight line with no changes in speed or stops. Velocity and speed are very similar, but velocity accounts for magnitude and direction. Meanwhile, speed only accounts for magnitude.
So that would mean that our speed graph would be a straight line since it's constant speed and it doesn't represent direction. So yeah, that makes sense.
Let's not forget that the speed and velocity are also in meters per second, so we should always check our units.
Yeah, you guys don't need me here, you basically get it. Lastly, to our velocity graph. It will start off by heading in a straight line due to constant speed towards the positive direction, but once I return home, I start heading in the opposite direction, which is why it becomes negative and continues.
Michelle, you are such a lifesaver because I was definitely not going to pass this class if I didn't get past chapter 2.
All right. I don't want to be that person, but listen. Shouldn't we try and put this put the scenario into an equation or something? Try to put it into the physics perspective, like how we would get it in class. I understand graphs, but can we turn this into questions a little bit?
Yeah, I'm down. Let's come up with our own problems and then explain it to each other. It's the best way to learn this stuff.
Okay, off we go.
So for our first question, it states, Michelle drives to her job at an average velocity of 11.17 meters per second for 15 minutes. What would her final position be since her initial position is 0? Using our equation, we converted 15 minutes into seconds, which gave us 900 seconds. And using our equation, we multiplied our velocity, 11.17 meters per second, times 900 seconds, plus 0, which gave us our final position, 10,053 meters.
I created a problem that will show you guys that you don't always have to use a kinematic equation and that it really could just be as simple as converting factors. So my question was, Michelle drove for a total of 14 minutes to the grocery store and back home. The distance between her house and the grocery store is approximately 1.8 miles. What is the average speed of the car in meters per second? So if her distance is 3.6 miles and the time was 14 minutes, you would just multiply that by the conversion factor of 5,280 feet over 1 mile, multiply that by 1 meter over 3.28 feet, and multiply that by 1 minute over 60 seconds. And once you multiply the numerator and the denominator, you would have the average speed of 6.9 meters per second.
Let us say Michelle continues to move with a velocity of 11.17 meters per second, but slows down to stop at a red light in 5 seconds. What would be her average acceleration while stopping? In this case, we know her initial velocity was 11.17 meters per second, but we are trying to get it down to 0 meters per second in a span of 5 seconds. So the formula that we would use is change in velocity is equal to velocity final subtracted by velocity initial, which would then translate to 0 minus 11.17 meters per second. And now to find the acceleration, we take our change in velocity and divide it by our change in time, which is 5 seconds. Negative 11.17 meters per second divided by 5 seconds equals negative 2.234 meters per second squared. The negative sign indicates that acceleration is moving in the opposite direction, which is slowing her down.
Well, guys, I think this study has finally concluded. Do you have any questions?
Nah.
Thank you so much for your help, Michelle. I definitely owe you big time.
Have a good day, y'all.
Bye.